Welcome to The Explainer. Today, we're going to follow the life of data in the cloud. We'll track its entire journey to figure out how we keep it secure every single step of the way, from the second it's created to the moment it's gone for good.
Okay, so let's get right into it. What is a data lifecycle? Honestly, it's just the life story of a piece of data. You can think of it like a biography, and every single chapter in that story needs its own security plan to keep it safe.
And that story, that journey, it breaks down into 6 critical phases. It all kicks off when data is created. Then it gets stored, used, and shared. Later on, it's archived for the long term, and finally, it's securely destroyed. Each step is a link in a security chain, and they all have to connect perfectly.
So here's our game plan. We're going to trace that journey and look at how to lock down each step using Microsoft Azure as our guide. Then we'll see what happens when that security chain breaks. And trust me, it does. We'll wrap up with the big lessons you need to know.
For this explainer, we're zeroing in on Microsoft Azure. And you might be asking, why Azure? Well, it's one of the biggest players in the game, and it has this amazing suite of security tools that just so happens to line up perfectly with every single phase of the data lifecycle.
Everything begins right here, in the create phase. This is where you have to get it right. First, you have to classify your data. Is it public knowledge or top secret? Then you encrypt it right away, from the very start. We control who can even create data using something called Role-Based Access Control, or RBAC. And those all-important encryption keys, they get stored in a digital fortress called Azure Key Vault.
Okay, next up, the store phase. Once data exists, it needs a safe home. The big goal here is what we call encryption at rest. It's like locking your data inside a digital vault. Azure Storage pretty much handles that for you automatically. But we add extra guards, like firewalls, to make sure only the right people can even get near the vault's door.
Now things get interesting. In the use phase, data is buzzing around, being processed by apps. And the real challenge is protecting that data while it's moving. We do that with strong encryption called TLS, but just as important, we use tools like Azure Monitor, which is basically a security camera, that logs every single interaction. Who touched the data, when do they touch it, and why? You absolutely have to know the answers.
Let's be honest, sharing is where so many security plans fall apart. Just sending out a public link? That's a huge no-no. The right way to do it is with temporary, super specific keys called shared access signatures, or SAS tokens. Think of it like giving someone a digital guest pass. It controls exactly who gets in, what they can do, and, this is key, for how long. Once time's up, that pass is useless.
So what happens when data isn't needed every day? It goes into the archive phase. This is all about long-term storage, usually for legal or compliance reasons, and the data often has to be unchangeable. We make that happen with something called warm storage, which stands for write once, read many. And it's exactly what it sounds like. Once you write that data, it is locked down. Can't be touched, can't be changed until its time is up.
And that brings us to the end of the line, the destroy phase. And I gotta tell you, this is way more than just hitting the delete button. The most secure method is called cryptographic erasure. Instead of trying to shred the data itself, which can be tricky, we just destroy the encryption key that unlocks it. It's simple, really. No key, no data. It's gone, forever.
So, what we just walked through was the perfect scenario, the textbook version where every single link in the security chain is rock solid. But what happens when just one of those links breaks? Because that's where theory crashes into reality, and one tiny mistake can bring the whole thing down. Two of the most common and scariest failures are misconfigured storage and weak key management. Misconfigured storage? That's like leaving the vault door wide open for anyone on the internet to walk through. And weak key management? Well, that's like leaving the key to that same vault right under the doormat. It makes all that fancy encryption totally worthless.
Now you might be thinking, okay, that's a nice theory, but does this stuff actually happen? Oh yeah, it happens, and the consequences can be massive. Let's look at a major real-world example that shows exactly how this goes wrong.
Back in 2021, there was a huge data leak involving Microsoft Power Apps. So what was the root cause? You guessed it. The official investigation found it was all because of failures in the store and share phases of the lifecycle. Someone simply didn't set up the access controls correctly.
And the impact? It was absolutely staggering. 38 million.
Let that number sink in. 38 million sensitive records were just exposed to the public internet. We're talking private employee data, even COVID-19 vaccination info. It is a brutal reminder that a simple mistake in just one phase can be a catastrophe.
All right, so we've seen the right way to do things, and we've seen a real-world disaster. So what are the big takeaways here? What if we really learn from all this?
It really all boils down to 4 key ideas. First, your security has to be end-to-end, because you're only as strong as your weakest link. Second, identity is the new firewall. It's all about controlling who gets in. Third, encryption is awesome, but it's not a silver bullet. Without protecting your keys, it's useless. And maybe the most important lesson of all, the tech can be flawless, but human error, a simple misconfiguration, is still the #1 reason data gets breached in the cloud.
Okay, before we wrap this up, just a quick word on where all this information came from.
This whole explainer is based on a really thorough academic analysis that pulled together information from a ton of credible sources, including official documents from Microsoft itself and the security standards from NIST, the National Institute of Standards and Technology.
And this deep dive was put together by Asnal bin Ahno from University Technology Malaysia as part of a course on cloud computing security. As we've seen, this stuff is a continuous chain of responsibility. So I'll leave you with one final question to think about. In your own world, what's the weakest link in your data security chain?